Marco Ribeiro, Senior Researcher at Microsoft Research. Welcome to the Data Exchange Podcast.
Thank you for having me.
And thank you, belated thank you for giving such a great talk at the NLP Summit. And you can go to nlpsummit.org to see Marco's talk. Um, so today we're going to talk about some recent work that Marco and some collaborators have done in the area of natural language models. But before we do that, Marco, for our listeners who have followed Microsoft research over the years, so these days, what does it mean to be a researcher at MSR? Does it mean focus on published papers, work with product groups? So what's the mix there?
I think it's hard for me to say anything about Microsoft research in general.
Yeah.
I can talk about my experience, which I know pretty well.
Yeah.
And in my group, they kind of let you decide where you want your impact to be, whether you want it to be mostly on publications and contributions to the academic community, or more of the tech transfer kind of thing where you're having impact on products, or both. They're happy if you do either or both, but it's up to each individual researcher to decide. So it's great that they give you a lot of freedom in that respect. And some projects lend themselves more easily to the tech transfer kind of thing. Other projects are more exploratory and it's harder to imagine them immediately changing anything in any product. And that's fine. They reward you for both kinds of contributions.
That's great, actually. So, so like I said, we're going to focus the conversation on your recent work on a project called Checklist, which is focused on natural language models. So, a bit of background, Marco. So, I know that your background is in machine learning, but have you always been interested in NLP and natural language?
Yeah, I've always liked NLP. It hasn't really been a focus area until a couple of years ago when I started to basically almost exclusively do NLP. But yeah, I've always liked
So,
NLP.
what
Even
what
even from my first papers, I had some NLP examples in there.
so what drove the shift in focus a few years ago? What prompted you?
It was kind of an ad hoc thing where the projects we were doing were kind of leaning that direction and specializing a little bit more. So in 2018, I wrote a paper on adversarial examples that only made sense for NLP. Basically, it did not make sense for any other domain. And that project kind of spawned other projects, including Checklist. So it's just kind of random. I'm working on stuff that's not NLP. It just has been a while since I've been focusing mostly on NLP.
So speaking of which, so checklist is an interesting project and paper, which I will definitely link to both the GitHub repo and the paper in the episode notes. So I guess the idea here is you folks wanted to inject more rigor into how people develop NLP models, right?
Particularly with like the common practice of just having a test set and
So
measuring accuracy on that. It's just
Marcos,
not
Marcos,
enough.
Marcos, start over. You got cut off.
Oh, sorry.
Yeah, yeah.
Yeah, particularly focusing on evaluation. What we tend to do in machine learning, just looking at some validation set or some test set, or even a benchmark of test set, it's just not enough to get insight as to work. And we've been seeing throughout our research of a lot of significant failures that do not get caught by the standard approach. So we thought, hey, let's borrow from software engineering. We know how to test software. Why don't we apply the same stuff to NLP or machine learning in general? But we focus on NLP.
So let me drill down for our listeners who are use NLP maybe in the more traditional way. So the traditional way is I have labeled data, I split it into a training set and a validation set, train on the training set, test it on the validation set. So that's not enough.
I don't think that's enough. I think that's a good start, but I don't think it's. what typically happens is you get the whole data set at once. You use some data collection and you get it all at once, and then you split it. The problem is if your data collection has some peculiarity, some bias in there, it's going to be both in the training and in the validation and in the test set. So your model can exploit that, and that's a concern.
Was checklist kind of a natural natural continuation of what you described earlier? You were working on NLP adversarial examples. Is that where the idea for checklist came about?
Yeah, so here's how I remember it coming about. I may be wrong, but I remember it like this. We were on adversarial examples. And in that paper, we had this technique that would take an example and extract a rule out of it. So it would say, look, whenever you replace what is with what's, your model makes a mistake, for example. So we could extract these rules. Oh, I think I lost you. Did you hear me?
I'm here. Yeah,
Sorry about my internet. So whenever so we could extract these rules that said, look, replace this with that. This is what happens. And a friend of mine was like, hey, like you have these framed as adversarial examples, but this should just be unit tests. Like you should just run this on any model. Like it should never change any prediction if you change what is to what's. Like, why don't you just make this into unit tests? And that got me thinking, why don't we unit test in general? Like not only this adversarial example, why don't you just do unit tests for NLP? And I think that's how I started going to this direction. And then we had another paper in the middle where we had one particular kind of test where we're trying to check for logical consistency, but then decided to just broaden it out and say, hey, let's just do this in general rather than specific things here and there.
So checklist, as I understand it, is like black box or behavioral testing applied to NLP. So Marco, for those people who are not familiar with behavioral testing, so give us a high-level description of what it is.
Yeah, it's very simple. If you're testing a piece of software and if you have access to the implementation, you can tend to write the test in a way that fits the implementation well. So you end up not testing cases where the implementation doesn't work. But if you treat it as a black box, you're like, I don't know how this does it. I only know what I expect given the input behavior. That's behavioral test. And we're doing the same have to with machine learning. You can't go look into the code or into the model for the most part. So the assumption is the model is a black box. We're going to test different behaviors. What happens if I have examples like this? What happens if I perturb examples in a certain way? Does it behave according to what I expect? Yes or no? So the advantage is it works for any model, right? And you can compare different models and stuff.
So in some ways, you literally don't care about the details of the model.
I don't care at all.
Yeah. So okay. So that's behavioral testing. So then, how do you do that in NLP?
So here's the problem. When you're doing software engineering, typically even if you decide to do behavioral testing, you're testing individual functions typically. So you're testing, hey, I'm going to implement a sign function here. You know what sign looks like, input and output, or you're implementing whatever you have, what those small units are that you're trying to test. For NLP, that's much harder. So part of the contribution is telling people what to test different capabilities of the model. Because NLP models deal with language, there's general enough capabilities that we think across the board. So for example, whatever task you're doing, your model has to have a certain vocabulary to deal with that task. So if you're doing sentiment analysis, an important part of that vocabulary is, do you know which words carry sentiment or not? Does my model work when I put good, bad, great, excellent, and so on? Now, if you're doing question answering, maybe those words are not the important part of the vocabulary, it's something else. The point is just that you always have a vocabulary that you care about. Or another example of a capability we always test, negation. Negation exists in natural language. How it's going to manifest in a task is you have to figure out and write a test specific to that task, but negation always shows up somehow. So we're saying test negation. So this is us telling users what to test, Another part of checklist is telling people how to test. And that we also borrowed from software engineering, a lot of things. One is just test very simple examples, unit tests, basically. We're calling them minimum functionality tests. So to keep going with the sentiment analysis example, if I want to check if my model understands negation, it better work on, I don't like this. This is not a good movie. This is not a bad movie, and so on. So we should definitely test those. And the thing is, if you take a standard data set, it's not going to have those examples most likely. Like if you take the standard data set for training sentiment analysis, it's composed of complicated reviews that people wrote. And people typically don't write a review that says, I don't like this. So you end up not testing. Does my model work for that kind of simple stuff? And you should definitely test that to see if it does. So that's one kind, and we have others as well. We can
So
go into it.
let's make this concrete for our listeners. So let's say I'm building a text classifier. I'm in a newspaper, and I want to classify, is this going into the front page, the sports section, the business section, the movie section, and so on and so forth. So then I built the classifier. So then how do I now start using checklist?
So here's the process. Check matrix, a matrix that says this is what you should be testing and how. So the first step in that matrix is going to be what's important vocabulary. So you want to make sure that if you have articles that are clearly about sports, that they end up in the sports page rather than on the religion page, for example. So you would author or get from existing sources very simple examples, minimum functionality examples, where, okay, this is an article clearly about sports category. This is an article clearly about finance. Does it end up in the finance category? That's the first step. Next step is trying to imagine invariances. So if I have an article about sports and I change from one sport to another sport, it should still be classified as sports, right? So if I have an article about baseball and I change it to tennis, even if everything else remains the same, it should still be classified. So thinking about those invariances is something that we do as a kind of test. And so on and so on. So the process will guide you what you have to test for. So another example, testing another invariance is if I change the date of the article, that should not change whether it goes into sports or finance. It may change whether it goes into the front page or not, but not between different categories. And it's basically matrix filling. You go through the matrix and you imagine, hey, what could happen here? What kinds of behaviors do I want to make sure my model is doing here and there? This is one approach that's really helpful. Another approach is bottom up. You look at a few specific examples and you try to place them on the matrix. So for example, you look at an article that got misclassified as finance, and you're like, okay, I think it got misclassified as finance because I have this property here. It's talking about how much money this player was paid or something. And then you create a test around that and you say, where does this fit in my matrix? I want to make sure it doesn't happen, or I want to make sure I'm checking for that. So it's basically a very guided process where you follow, and we have a lot of tooling to help people do that as well. I hope that makes sense.
Yeah. So it sounds like a lot of the testing can be done by someone who's not necessarily an expert in building models, but knows a lot about the underlying data. Because a lot of the, as you describe it, a lot of the tests are actually examples, right? So
a lot of all of the tests are either examples or perturbations and expectations. So the person absolutely has to know how the model is going to be used way more than they have to know anything about machine learning or how the model was trained. Because we're talking about behaviors, we're talking, I want my model to behave in this way. So you're absolutely right. You don't need a machine learning person to do this. You just need someone who can specify what the model should be doing.
So in software testing in QA, one of the big questions is test coverage. So how do I know in the checklist context, how do I know I have adequate test coverage?
It's a great question. I don't. It's something that I'm working on actively right now. So in the paper, we didn't even talk about this. What we did was give people a bunch of tools so that they can get more coverage than if they were doing it alone. And we show that use tools, you get way more coverage. But that doesn't say this is enough. So far, we haven't had this problem because every model that I've tested failed quite a bit, even on the test that I already had. So it gave people plenty of things to work on. When I come to this point of, hey, the model is passing all the tests, can we have confidence that we tested everything? That would be a concern. But even right now, I'm working, observing different teams at Microsoft trying to use this process to test their models. I'm trying to figure out what are the pain points, what are areas that people don't cover, how can we make sure that people really are exploring all the different facets of language that they should be exploring their model. On an update to checklist that gives people even more guidance so that they can be more sure. But I still don't know how they can be, like, I can't give people a quantitative metric of saying, okay, you've covered 90% as you could in software engineering when you have more defined inputs and outputs. So long way of saying, I don't know, but I'm working on it.
So I think one of the nice things about this, the notion of black box testing, particularly Marco in the context of NLP and machine learning, is that NLP models tend to be composed in a pipeline, right? So you might do some tokenization here, and named entity recognition, another model, and another model. So in the checklist world, can I just treat this entire pipeline as it's one big model and then just do checklists end to end?
To test individual model, want to, but what the customer is going to see is that end-to-end result, right? Like if every model works, it seems like it's working well, but when you put them together, everything, you want to know that the whole working. So in general, I think it's better to test end-to-end.
So, by the way, for the people who are not software engineers listening to this, they're more in the data science and machine learning world. What do people in software engineering think about black box testing? Is that something that has a that is widely used?
I don't know how widely used it is. I think unit testing, certainly people do a lot. Integration testing, they do a lot. But there are some techniques for black box testing that I haven't seen widely used, but they're very useful. One example is metamorphic testing, which is basically what I was saying before, of applying perturbations where you know what should happen to the output. So saying, I don't know what the prediction should be for this input, but if you change the, I don't know, the punctuation, the prediction shouldn't change a lot. That's the kind of property that you can check even for unlabeled data. And that's something that people do in software engineering as well. It's a little more advanced. I don't think people use it as often as they do unit tests. They should. It's really useful and widely applicable.
So I imagine you've tried to use checklist on some of these famous Sesame Street state-of-the-art models.
Yes.
Yeah. So because right now in NLP, when people, so I guess one of the things in your paper is that okay, so you can do the classic test validation split, and then you have one number, like that's your benchmark. So with checklists, does that mean we have to revisit how we benchmark what is the best language model? So how does this affect NLP research as well, not just NLP production?
I think it does affect it. Let me give an example. One of the tasks we have in the paper is Quora question pair, and that's taking two questions asked on Quora and predicting if they're the same intent, if they have the same intent. We tested state-of-the-art models, BERT and Roberta, and the difference between them is not that high. Like if you measure accuracy on the test set, I think it's like 1% difference. So you think that they're basically interchangeable. But Roberta performed much better. Both were kind of bad on some of the tests that we ran, but Roberta was much better. And you kind of understand where it's doing better. So here's an example I had here. this is a model that benchmarks would suggest is better than humans at predicting whether questions are duplicates or not. And we had a test, for example, where we had questions like, here's a pair. Will it be difficult to get a US visa if Donald Trump gets elected? That's one question. The second question is, will the US accept Donald Trump? So clearly those two questions are not duplicates, but both Bert and Roberta, for examples like these, imagine others like these, about a third of the time they predict these are duplicates. So if you look at accuracy, you're saying, okay, this model is basically perfect. It's got 95% accuracy or something. But if you look at specific failures, you're like, okay, there's something fishy going on here. Something is weird here. And this is just one example. We have a whole table of examples that make it clear that the model is not really figuring out how to solve the task.
But then, yeah, you're a machine learning researcher. You know that machine learning researchers, they want to benchmark against one number, right? Accuracy. So if you start using checklists to compare different models, how would that work for researchers?
Yeah, I was like from 1911 or something, the year that I was born, where the author was arguing that the goal of experiments is not just to say my curve beats your curve, is to get understanding. And I completely agree. I understand why people want a single number and say, okay, I'm winning. But at the end of the day, you want to understand what is going on. It's
Right.
good to have a single number if that number represents reality. It's just very hard to get a single number that represents what we actually care about. So even though checklist is maybe a little more work, you have to look at a few numbers rather than a single number. I think the insight that you get from that is worth it. Because if you're a researcher and you say, okay, my model cannot deal with negation at all, that gives you a direction. You're like, okay, let me understand why. Is it that I need a new architecture? Is it that I'm missing training data that has negation? What is it? So yeah, I think I can justify not having just a single number.
So,
I think it's worth it.
So Marco, for the listeners out there who are working in industry, in machine learning and data science teams, so they're listening to this episode, they want to get started using checklist. So what's the best way to get started in terms of probably just use it on a simple model first, and then build up your confidence, right?
You know, since model is a black box, again, it doesn't matter what the model is.
Yeah,
I think
that's
the
true.
best way to start is to take whatever problem you're working on right now and trying to write simple tests for it. So in the GitHub repo, this is open source, by the way, but so in the GitHub repo, we have tutorials, Jupyter notebooks. It should be very easy to follow along and change it to whatever task people are doing. And I've gotten feedback from people who followed exactly this path, saying, look, I'm working on something completely different. I just followed the tutorial to whatever it is that I was doing and found a bunch of bugs immediately. Because right now what people do is just train and test with. Any testing tends to reveal interesting stuff. If you spend half an hour testing, 1 hour testing, it's usually enough to get you something. If you spend 5 hours, it gets you way more stuff. But if you spend even a little bit of time, tends to give big returns, I found.
By the way, one of the hot topics in ML and AI right now is fairness and responsible AI. So I imagine this is something that checklists all there has capability around too, right?
Yes, one of the capabilities that we suggest people always test is fairness. And we have tested a bunch of models for fairness. Typically, research models will struggle quite a bit because there's nothing around them to even try to mitigate potential biases. But even commercial models, if you don't do this kind of testing, it's very likely that you have problems that could put you in the news for all the wrong reasons, not to mention the detrimental impacts to society. So at Microsoft, people really care a lot. We care a lot about our products being fair and so on. So I've seen a big push in adoption for has been around fairness issues. Seeing a lot start there. Rather than starting with quality, they're starting with, let's make sure that we're testing our models for fairness as thoroughly as we can.
So this is baked into the kind of before we deploy. This is baked into the process.
Right, right.
So Marco, it's
And
what's
again, this is one more thing that I'm working on actively is expanding that. Sorry, go ahead.
no. I was just going to ask. So what's next for checklist?
Okay, so right now with checklists, as I said, what I'm doing is following different teams using it and figuring out what the pain points are. And I've already learned a few things about what the pain points are from the version I have in the paper. And the goal, of course, is to fix those pains so that it's trivial, so that anyone can use it immediately and find bugs. So a few things that we're seeing is giving people more guidance, more examples in each category in the matrix so that they don't have to rely so much on creativity. It's a fine line because we want people to be creative, but we also want to enable them, to give them the building blocks so that they can be creative with. And those building blocks is something that I'm working on right now. Big question is, what do you do once you find the bugs? I always get asked this question in any talk that I give. And it's an obvious question. You find a bug, you want to fix it. And right now, it's not easy to fix the bug. Some are not. Sometimes it's obvious. Oh, I just need to get more training data. I just need to add a filter here, a block word or something like that. But sometimes it's not. So as I follow teams that are finding bugs and fixing them, I'm trying to figure out what can I incorporate into checklists to make even that part easier as well. So I think there's a lot of value here for industry across, obviously at my but for anyone. So I'm a little more into refining the process. I'll publish a journal paper in the meantime too. I don't know. We'll see where it goes.
So automation is something that's happening a lot in software, particularly in QA and testing. But the way you described the checklist, it seems like at least in the for creating samples, it requires a lot of human judgment still. So checklist might be hard to automate completely, huh? Unless you use GPT-3,
It's hard
natural
to
la-
automate what we
nat- natural language generation with GPT-3 to generate your test samples.
Yeah, you know what? What we're doing is a mixture of automatic and users. So we're not using GPT-3 yet, but we are using Roberta, for example, to make suggestions. So when someone creates a test, we create a bunch of suggestions around that and say, hey, what do you think about this? What do you think about that? So it's still a mixture. You can't just trust these models blindly because they're not good enough yet. But you can get this mixture of, like, instead of you having to do everything by hand, you get some help, but you're still judging what are these suggestions? Do they make sense, and so on. And that's what we're aiming for, like a hybrid human AI collaboration, even as you create the test.
So in closing, Marco, checklist is NLP specific, but philosophically, what you're doing, you could do in computer vision, you could do in other machine learning, even machine learning with structured data. So is this something you're also thinking about in terms of having a checklist for all of ML, not just NLP?
When we started, we were doing all of ML. Like, I had a bunch of tests for vision, a bunch of tests for structure prediction. It's just that very quickly it became clear that the guidance had to be specific. Like, even though the principle is broad, like, if I'm telling people about negation, co-reference, and so on, like, I can't do the same for everything, especially if you get structured data. Every data set is different. So it's harder to give people that kind of guidance. And for vision, it's harder for people to perturb instances. So for text, I can give you an example and you can tell me how it could be different, and it's still text. For images, it's hard to say, oh, just add a dog in that image. and have it still look natural. So I think NLP was just more straightforward to do something that's general and widely applicable. The principle, I'll definitely write some tests in the spirit of checklist. I just haven't been able to figure out yet what that whole process looks like and what that guidance and what the tooling looks like. For vision, that seems way more challenging, and for structured data, it seems harder to generalize. Language is general, no matter what task you're doing, but if you have a medical data set as opposed to some industrial data set, it's hard to figure out what's common, what abstractions you need to share across them.
So actually, one final question I forgot to ask earlier, which is, what is the level of language support, language coverage? Is it only English for checklist?
So the principles are general. I don't know enough languages to know whether some of the categories in there do not apply to specific languages. The tooling is mostly for English. We do have suggestions in like 90 languages or something because we use multilingual BERT, and that works. And we have icons for a bunch of languages. So for example, we have names, we have country names, we have city names from every country in the world in most languages that I could figure out. So we do have some tooling for multilingual stuff, but a lot of the tooling is specific for English, just by virtue of what tools are available off the shelf.
So actually, one final question, which is, so the project is fairly new, so you're following some teams inside Microsoft, but have you heard of other users outside of Microsoft?
I have. I have heard of more users outside of Microsoft than at Microsoft. Although that's changing now. Let me change that. At first, I think a lot of people saw it at ACL in the conference, and people reached out to me and said, "Hey, we're using this and we're finding all of those bugs." People from other companies or from startups and so on. And then at Microsoft, it makes a difference that I'm there, right? So it's easier for people since I'm there to adopt it. So I've had more success stories where people are doing it on their own outside of Microsoft than at Microsoft, where I'm typically somewhat involved. But I have definitely heard of a bunch of people using it at different companies. I won't name the names, otherwise they'll get in trouble. But
Wow. So thank you, Marco. This has been great, and it's actually also quite heartening to hear that the ML and specifically the NLP community is kind of moving in this direction of more rigor, more testing.
I certainly hope so. And yeah, thanks for having me. This is great. But I think that if you follow the trend, people care more and more about stuff that actually works. And it's become clear that you can't just take a benchmark and assume that's going to reflect reality. So I think we're going that direction. Yeah.
Thank you.